Okay, welcome back. This is Mr. Hassan's Maths channel. I'm answering questions from the January 2023 Pure Mathematics P4 paper from Edexcel, the International A-Level exam. And I'm going to go through each question in this paper one by one. And I'm going to make one video per question and save that video in the playlist which is related to this paper, and also the playlist related to the topic that it comes from, so I can build up my topic playlist as well as my paper playlists. And another thing that I'm going to do, I'm not going to just do like a walkthrough in terms of just writing down the answers as if I'm copying from the mark scheme without any explanation. I'm going to go through some explanation, sometimes in depth, depending on the type of questions that I have got in my mind from students that I teach or students who send comments on the channel, to clear up some of the misconceptions I see or the questions that are being asked, from that. So I use this as a tool to help me to teach my students, whether they are students that are from the channel or students that I teach at school, and to try and help them understand certain concepts. So sometimes I might take a bit of time explaining a question, longer than it would take anybody to answer it in the real exam, but that's because I'm using this as a teaching tool, so I go sometimes into more details. All right, so please bear with me. And those of you who are just coming here to check your answers after you have done the paper, right, then going to the mark scheme would be more efficient for you, if you don't need to listen to some of these explanations. But if you have a situation where you're not being taught properly, or you didn't pay attention while you're being taught properly, or any reason where you need some more in-depth understanding, then this might be the right format for you. Okay, so I'm going to now start with question number one. So question number one, very typical type of P4 question, and this is a very kind of easy, kind of basic one. It says write f of x in partial fraction form. Okay, so there's from the first chapter, well, now it's the second chapter, I guess, of P4, which is partial fractions. So we have to split this up into partial fractions. So basically what it means by partial fractions, and the word partial has the word part in it. So basically we have to split this apart into two separate fractions. And that's what it basically means. So it's kind of like the reverse of adding fractions together. It's splitting the fractions apart. Now what we'll notice in P4 is we always are going to be dealing with fractions which are linear factors, or you could have a linear factor which is a repeated root. Like you could have something like this, where you've got a squared on the whole bracket, and that's dealt with in a particular way, which you can see in some of the other videos which deal with that. This one only has these very basic repeated factors, okay, linear factors. So what we do is we take this 5x plus 10 over 1 minus x times 2 plus 3x, and we write it in the form it would be as if we were adding the two fractions together. So when we're adding the two fractions together, we would multiply the denominators to find the LCM. So one would be 1 minus x, and the other one would be the denominator of 2 plus 3x. And what we have to find is what those numerators were, such that this becomes 5x plus 10. So we've got to find what a and b is. And when we've done that, we have then split this up into two separate fractions, which is what we're asked to do. That's what it means. So we need to find the value of a and b. And what we can do is we can use, this is an identity. This is exactly the same as that. So if I get rid of the fraction from this whole identity by multiplying both sides by the denominator, which is 1 minus x times 2 plus 3x, on this side I'm left with 5x plus 10. And that's identical to this side. Now if I multiply this by 1 minus x times 2 plus 3x, the 1 minus x's cancel, and I'm left with a times 2 plus 3x. And if I multiply this by 1 minus x times 2 plus 3x, the 2 plus 3x's cancel, and I'm left with b times 1 minus x. So it always works out like this, that this is multiplied by the one that's not underneath it, and this is multiplied by the one that's not underneath it. Sometimes it might be two that are not underneath. So now we have set up our identity. Right. From this identity, we can now calculate the values of a and b. Now there's a variety of ways we can do this actually. Now if you have something like here 1 minus x, if you have a number that you know that you can substitute into one of these brackets to make it equal 0, that will eliminate that particular constant, and you can find the other unknown constant. So for example here, I know 1 minus x becomes 0 when x equals 1. So if I replace 1 in this bracket, the x with 1, this becomes b times 0. The b term is now eliminated. And if I replace 1 in the other places where this x is in, then I'll be able to find what a is. So if I use x equals 1, this is going to be 5 times 1, which is 5, plus 10, which is 15. This is going to be a times 2 plus 3, which is 5a. And this is going to be 0. So I'm left with 5a equals 15, from which right away I can say a is equal to 15 divided by 5, which is 3. So I now know this is 3 over 1 minus x. Now I've got to find what b is. Now for b, I could do the same thing if I wanted. I could say 2 plus 3x is equal to 0. And so I could eliminate the a. So I say that means 3x is equal to negative 2. And x is equal to negative 2/3. If I substitute negative 2/3 instead of 3, this becomes 0. All right, then I've got these left. But then I have to substitute negative 2/3 into these two as well, which it's doable. It's not a big deal. But when you end up with fractions, it just makes your life maybe sometimes a bit more kind of hassle than what you want. So there's alternative methods you could also use, which are perfectly fine for you to do this. And the other method that we could use, and sometimes we're forced to do this because sometimes this elimination method doesn't work. You can't get everything from that sometimes. But we can compare, for example, the coefficients of, say, for example, x on both sides. Compare, the coefficient of x on the left-hand side and the right-hand side. So if I look at the left-hand side, the coefficient of x is 5. And the coefficient of x on the right side must be exactly the same because it's an identity. So what I can say is, all right, what would be the coefficient of x on the right-hand side? Well, the x term will be when I do a times 3x, that's going to be 3ax or 3a. And when I do b times minus x, which is going to be minus b. Those together combined will give you the coefficient of x on this side. So we have 3a minus b equals 15. We now know that a is equal to 3. So I can replace the a with 3. So I have 3 times 3, which is 9, minus b equals 5. Okay, it's 5. All right, because that was 5x. So therefore, we're going to have b equals 9 minus 5. b equals 9 minus 5. So b is equal to 4. So now we know what a and b are. We can just replace the a and b with 3 and 4, and we have finished part A. So we can now say that 5x plus 10 divided by 1 minus x times 2 plus 3x is the same, is identical to, you can say a, which is 3, over 1 minus x plus b, which is 4, over 2 plus 3x. So there's the answer to part A of this question. There's the answer to part A of this question, and that's finished. Part A. Pretty simple, 3 marks there, partial fractions. Now we're going to move on to part B. Now for part B, part 1, it says hence, meaning using this answer that we've found. Finding ascending powers of x up to and including the terms in x squared, the binomial series expansion of f of x, giving each coefficient as a simplified fraction. Just one little point before I move on actually. Supposing, of course, you don't have the mark scheme for this question. During the exam, you don't know whether you've done it right or wrong. Okay, and you want to make a quick check to see if you're correct. Well, you could add these two fractions together. And we know to add fractions together, a quick way is to just multiply the denominators, which you don't have to actually multiply out. But this times that gives you 3 times 2 plus 3x plus 4 times 1 minus x. So this is like a check to make sure. All right, so you end up with 6 plus 9x plus 4 minus 4x over, you have 1 minus x times 2 plus 3x. So you end up with 9x minus 4x, which is 5x, 6 plus 4, which is 10, 10 over 1 minus x times 2 plus 3x. And that's exactly what we started out with. So we know that this is correct, that we've done this correctly. So that's just a quick little check you can do just to make sure that you have done the right thing. Because if you check like towards the end and then you've got to go back and correct all of this stuff, because this would also be wrong based upon that, then that's a lot more work. So if you do a quick check over here, once you found the values of a and b, if you just add these two fractions together and confirm that it gives you exactly what you started with, then you know that you are correct and you can continue. So of course, this is what you do in the real exam, especially if you do have the time to do so. All right, when you don't have the mark scheme to check. Okay, so that's what I'm going to try and also do, trying to give you some techniques for you to check your answers as you're going along in a quick way. All right, so B part 1, it says hence meaning, very important, hence means using your answer. And it's always going to be easier to use your answer in these questions. So hence is always the easy way. It doesn't say otherwise, it just says hence. That means using this answer, this result that you found earlier, finding ascending powers of x up to and including the term in x squared, the binomial series expansion of f of x, giving each coefficient as a simplified fraction. So basically, we have to take our f of x, write it in its new form, which is 3 over 1 minus x, plus 4 over 2 plus 3x, and rewrite it in a way that's going to make it easy for us to use binomial expansion. So we got to write it with the denominators in the numerator with a negative power. So you have 4, 2 plus 3x to the power of minus 1, and 3 times 1 minus x to the power of minus 1. So we got to take the expansion of these two up to and including the terms in x squared. Okay, up to and including the terms in x squared. And then it says you've got to write the terms. All right, so give each coefficient as a simplified fraction. All right, so now, so what I'm going to do is I'm going to take 1 minus x to the power of minus 1 separately. I'm going to expand that, and I'm going to put it back into this at the end. And then I'll do the same with this. So to expand this, we're going to use the formula that we have, and the formula sheet has this formula in it. So it's basically 1 plus x to the power of n equals, this is how the formula sheet writes it, something like this: 1 plus nx plus n times n minus 1 over 2 factorial times x squared. That's as far as we need to go in this question, but it continues on if you need to. N times n minus 1 times n minus 2 over 3 factorial times x squared. But the point for this formula, it must have a 1 here. The 1 can't be a 2, can't be a 3, can't be a minus 1, it has to be a 1. It doesn't matter what's here. Okay, it could be x, could be half x, could be minus x, could be minus 3 over 2x, it doesn't matter. It could be any type of, well, that must be a 1 there. Then this expansion works. So we can't use the NCR method because we have a negative power. That doesn't work with negative powers. All right, the NCR method is not, the NCR button is not designed for binomial expansion. It's designed for combinations, which is a topic in statistics, which doesn't deal with negative abstract type of values. All right, even fractional ends. Fractional and negative ends cannot be used in the NCR button. All right, it's a useful button in binomial expansion when we have positive integers only, not when we have negative or rational powers. But anyway, now what we're going to do is we are going to, when I say rational, I mean non-integers. Okay, now what we're going to do here is we're going to apply this formula to this particular situation. So we have 1, always have 1. 1 plus n. N is the power, so that's minus 1. I don't have to put that in the brackets, but minus 1 times x. Now x means whatever's in this place here, including its sign. So our x in this case is going to be this minus x part, right? So the minus sign has to be included in the x. So it's 1 plus nx plus, and then you're going to have n, which is minus 1, times n minus 1, which is take away another 1, that's minus 2, over 2 factorial, which is 2 times 1, times x squared. So it's minus x squared plus, and that's as far as we're going to go because we only want up to x squared, and we're going to be basically adding these two together, so we only need up to x squared. All right, so this is going to give us 1. Now this is going to be plus, and when you multiply these two, you're going to be positive, so it's going to be plus x. Here you have minus times minus is plus, the 2's cancel out. Minus x, when you square it, gives you positive, so it will be plus x squared, and that's as far as we need to go. Okay, so that's this part here. That is 1 minus x to the power of minus 1, which I'm going to put back in here. So I have to remember, I'm going to multiply it by 3 as well. All right, so that's the first step. That's this part here. Then I'm going to take the second one here, and I have to expand this. Now this one I have to be a bit more careful because I have a 2 plus 3x to the power of minus 1. Now, as I said, this formula works when we have a 1 here. this is a 2 here. So we got to get rid of that 2. Now what do we do to get rid of that 2? Because it's an expression, we can't just like, divide by 2 or anything like that. We're going to take this 2 out as a multiple of this whole bracket. So we're going to take 2, and then here you'll have 1, and because you have taken 2 out from here, you've got to take 2 out from here. That becomes 3 over 2. You have to divide it by that 2. This will be the same as this, you see. This is 2 plus, if you multiply them, you're going to get 3x. But all of this, including the 2, is to the power of minus 1, because it's inside this bracket. So what we can do now, we can split this into 2 parts, just like if I have a times b to the power of n, I can write that as a to the power of n times b to the power of n. So if I have this to the power of minus 1, 2 to the power of minus 1 times 1 plus 3 over 2 x to the power of minus 1. All right, that gives me a half, because 2 to the power of minus 1 is a half. 1 plus 3 over 2 x to the power of minus 1. So now this part here becomes that. All right, now I can expand that. So I'm going to leave the half with it so that I don't lose that half there. So I'm going to expand this now using our pattern. Now this is ready for us to apply the pattern that we mentioned up here. This pattern is now ready to use in this question here. So I'll just make a bit of space and apply this pattern to this particular section. So now here we'll have a half times, I'll write the half outside. I'm going to have 1 plus n, which is minus 1, times x, which is all of this. So the x in this case is this term here with the 3 over 2. It's a positive term, so you're going to just put minus 1 times 3 over 2x plus, and then you're going to have n times n minus 1, which is minus 1, and then minus 1 minus 1, which is minus 2, over 2 factorial, which means 2 times 1, which is 2, times, and then again this, which is 3 over 2 x to the power of 2. Yeah, so that's as far as we go, because we only want up to this is going to be x squared term. You're going to need to go up to the x squared term. So this is going to be a half, and you're going to have 1, and this is going to be minus 3 over 2x, and here you have a minus times a minus, which is a plus. The 2's cancel out. I have 3 squared, which is 9, over 2 squared, which is 4x squared. So this is our half times 1 plus 3 over 2 x to the power of minus 1. So this is basically what this part becomes. I'm going to write that this is the same as 2 plus 3x to the power of minus 1. That's what that becomes. This is the same as that, okay? We just rewrote it. So now I can go back to my original part here. I have 3 times the answer for the first part, which is this, once we've expanded it. So I'm going to have 3 times this answer, okay? Because we got, remember, we have 3 times 1 minus x to the power of minus 1. So we have 3 times 1 minus x to the power of minus 1 plus, and we had here 4 times 2 plus 3x to the power of minus 1. 4 times, 2 plus 3x to the power of minus 1. So we have 3 times our answer for this section here, which is 1 plus x squared. 1 plus x squared. And then we're going to have plus 4 times our answer for this, which is, what I'll do is I'll just, that 4 times a half, which is going to be 4 over 2, okay, times 1 minus 3 over 2x plus 9 over 4x squared. So this gives you 2 times in the end, because we multiply the 4 by that half. So now this is going to give you 3 plus 3x squared. And this is going to give you plus 2 minus 2 times minus 3 over 2 is 3. The 2's cancel, so that's minus 3x. And 2 times 9 over 4 is going to give you plus 9 over 2x squared, which gives you, you have 3 plus 2, which is 5. You have 3x minus 3x, the x term is going to be cancelled out. You have 3x squared plus 9 over 2x squared. Well, that's 6 over x squared plus 9 over 2, so 6 over 2 squared plus 9 over 2 squared, which is plus 15 over 2 squared. So there is our answer in the end. Okay, so that is the expansion of all of this, okay, up to and including the term in x squared. Okay, so there's the answer. That's the answer to this question. And the next part of the question says, find the range of values of x for which the expansion is valid. So what I'm going to do is, I'm going to take it in the forms that I've written over here, and you'll see why in a minute. So I'm going to take, we have 3 times 1 minus x to the power of minus 1. 3 times 1 minus x to the power of minus 1 plus 4 times, I'm going to have 4 times, and I'll take it in this way. So I'll write it as 2 times 1 plus 3 over 2 x to the power of minus 1. I'll write it in this form because, and you'll see why in a minute. 2 times 1 plus 3 over 2x to the power of minus 1. Okay, those were the two forms, right? That was 4 times a half, which gives us 2. Okay, now, the range of values for which this expansion is valid. Now, this expansion is valid when the modulus of x is less than 1. And this expansion of this is valid when the modulus of 3 over 2x is less than 1. Okay, what's the reason for that? In fact, you can say the modulus of minus x, but no problem, it's fine. We can just take that value. Now, the reason being is because, you know, if you think about it, that number 3 over 2 and that number x, that term x is what goes into this bracket. Okay, if you continued on the expansion, you will have, you know, minus 1 times minus 2 times minus 3 over 3 factorial minus x cubed. And the next one will be minus x to the power 4, then to the power 5, then to the power 6, then to the power 6. It's going to get bigger. This power is going to get bigger. Now, if the value of minus x, if the value of this minus x has a magnitude which is greater than 1, then the value of each term is going to get bigger and bigger as you go along. Okay, and that will add to the value of the whole expression. It will keep getting bigger and bigger and bigger and bigger and bigger. But if the value of minus x is less than 1, if you square, for example, if you square 0.1, yeah, you're going to get 0.01. If you cube it, 0.001. If you raise it to the power of 10, 0.000, 10 zeros and then 1. Okay? So, well, 9 zeros and then 1. So basically, you're going to end up with something so small that it only affects like the 10th decimal place. Right? So as long as the value of this number that goes into this bracket, and the same here, the number that goes in here, as long as this number, okay, that goes in this bracket here, which is what you get when you get this ready to be, you know, when this becomes 1 here, whatever number goes in here, if its magnitude is less than 1, then the value of the expression as you keep going on and on, because this thing will go on forever. This will never stop. This expansion is infinite, because you'll always have a number. You will never get a 0 here. Have minus 1 because it's a negative integer. You'll never end up with a 0 here. If this was, for example, cubed, you would have, you know, 3, and then you'll have, 1 plus 3 times this, then plus 3 times 2 times this, then plus 3 times 2 times 1 times this. Then you have 3 times 2 times 1 times 0. And that will become, the whole thing will become 0. And the one after it will have 3 times 2 times 1 times 0 times minus 1. There'll always be a 0 there after that. So the expansion will stop. It will be finite. But with these negative integers, and also with fractional integers, you'll never get that case with a 0 in one of these. And the expansion will continue on forever and ever, never ending. Okay, and if the value of this thing here is more than 1, the value of the expansion will keep getting bigger and bigger and bigger. It'll be an expansion that will become really huge. Okay, and you can't say that it's equal to this or equal to that particular value. So this expansion is valid for us to stop it at this point, to say that this will give you the same as that, as long as the value of what goes in here is less than 1. So its magnitude could be positive or negative, but its magnitude must be less than 1. And then as you go to higher and higher powers, what you're adding to the whole expression will not give any effect to it, really. It will just affect in a very insignificant way, it'll affect the value of the expansion. So for this particular part of the whole expansion, we know the modulus of x must be less than 1. For this part of the expansion, the modulus of 3x plus 3x over 2 must be less than 1. So if we rewrite this in the form of what it actually means, in terms of inequalities, if the modulus of x is less than 1, that means x is always basically 1 away from 0, less than 1 away from 0. So the modulus of x is less than 1, so x is between positive 1 and negative 1. It's always going to lie between these two values, right? And if 3 over 2x is less than 1, if you rearrange that, okay, that means between minus 1, you have 3 over 2x and plus 1, okay? In which case, if we rewrite this for x, we can multiply this by 2/3. So this becomes minus 2/3 is less than x and 2/3. What you do to one part of the inequality, you do to the other. So if I multiply this by 2/3 to make it x, I must do the same to these two as well. So in this case, 2/3 is less, it's going to be over here. Okay, so this is negative 2/3 and this is 2/3. Okay, so what's common between these two inequalities? Well, it's this part here. So this is the answer. We can say the range of values of x for which this expansion is valid is x is between minus 2/3 and plus 2/3. Okay, I guess you can also say the modulus of x is less than 2/3. That's the same thing, but this is as an inequality. All right, so there's the answer to part 2. All right, so it's only worth 1 mark, and you know, it doesn't take much work for you to do it, but I want you to understand the reason behind it. Many people just memorize, you take this when it says 1 plus, and you find the modulus, you just say the modulus of that is less than 1, and you know, you see which one is, you know, the least one, and you take that as your answer. But they don't understand why that is the case. Why is it only valid for those values of x? And I hope this helps you, make you understand it a little bit at least. All right, so that concludes question number 1. It's a pretty straightforward question, question number 1, not too difficult. And yeah, so a nice, easy way to start off. So other questions from this particular paper can be found in the playlist that will appear in this section here at the end of the video. Other questions from partial fractions you'll find in this video over here, in this playlist over here, sorry. Other questions dealing with binomial expansion you can find in the playlist in this section over here. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.